Hello everyone and welcome in a new video, and in this video we are going to understand about CPU scheduling. Okay, this video is particularly to understand about that how the process is basically scheduled, means how what basically the scheduling times, what is the goal and what is the purpose of CPU scheduling, what basically it does, and we understand about two important scheduling algorithms, which is FCFS and SGF, first in first come and shortest job first. Okay, so we understand these things in this video. Now we start the video. So first of all, we understand about the CPU scheduling, that what is it function, what basically the CPU scheduling do. So CPU scheduling is basically make a selection of a process to run on a next that which process is basically run next on a CPU among all the ready processes, among all the processes, all the programs which is in a main memory. So that what should CPU scheduling do. So what it does, it make a selection of a process, it make a selection of a process, it make a selection of a process to run or to execute on a CPU among the different ready processes. Okay, so this is what the function, this is what the main thing that CPU scheduling do, it schedule the process basically. Okay, and what is its goal, why the CPU scheduling, the CPU scheduler basically schedule the process. Now what is the goal of for that, what is basically the purpose, what is the goal, that what basically we achieve after doing this. So the goal is we minimize the waiting time and the turnaround time. Now what is a waiting time, what is a turnaround time, we will see these things in a few minutes. So for now what you have to understand is that it minimize waiting time and turn around time, waiting time and turn around time. TAT means turn around time. Now what is TAT, what is waiting time, we will see these things in a few minutes, in a couple of minutes. Now what the other thing, what's the another goal that CPU scheduling do, CPU scheduling achieved is that it maximize the CPU utilization. What it does, it maximize CPU utilization, it maximize CPU utilization. What is the meaning of CPU utilization, or you can say throughput. Now what is basically this means, this means that the CPU cannot become idle for a minimum time, that CPU is become an ideal. Let's say an example that we have a process and we have a we have a CPU and we have process, let's say P1 and P2, and we have an operating system. So what happen is operating system, what a CPU scheduler, now CPU what it does, it schedule P1 to the CPU, it schedule P1 to the CPU. Now CPU is executing P1 program. When P1 is execute, what CPU scheduler do, it schedule P2 to the CPU. So now what you see, that CPU utilization is going on, CPU has not become an idle. Idle means CPU is not become an empty, CPU not become an empty means whatever the process is, CPU execute that processes. Okay, CPU is not become an idle. This is what CPU scheduling goal is. Okay, to maximize CPU utilization. We have so many algorithms. Some algorithm give a maximum CPU utilization, means when we execute those processes, CPU utilize very efficiently. It gives us a maximum throughput. It gives us a maximum throughput. But there are some algorithms which basically decrease the CPU utilization. For sometimes CPU become idle because that process was performing some other task. So that's why CPU has to become an idle. This is what happened in the case. We will see these things in a upcoming videos when we understand more about the scheduling algorithm. But what you have to understand now is that it maximizes CPU utilization, means CPU is not becoming idle now. And what basically the other goal is, like fairness. Now what does the fairness means? Fairness means that every process get a chance to get a CPU. Every process will get a chance to get a CPU. Means let's say that we have main memory, okay, and let's say in main memory we have P1, P2, P3 and P4. So what CPU scheduler do? It schedule P1 to the CPU. Now P1 is a very long process, it take a very long time. So is that mean that P2, P3, P4 is not getting a CPU? So no, it does not happen. We will see so many algorithms where those process who have a very small bus time. What is a bus time? Bus time means the execution time basically. Those process who have a very small bus time will get a CPU first, and those who have a very large time to those process who take very large time to execute a process will get a CPU later. So what it does, what CPU scheduler does, it gives chance to every process. What happen if one big process acquire a CPU? So the small processes will not get a chance to get a CPU. So these thing is not gonna happen in CPU scheduling. Every process get a fair chance to get a CPU. Every process got a chance to get a CPU. So this is what you can write as well, that every process will get a CPU. Every process will get a CPU. Okay, so you understand about this goal as well. Now the other goal is interactivity. Now what does that mean? Interactivity. Now what does that mean? What does the meaning of okay, so what is the meaning of interactivity? Interactivity means user want to see all the processes execute. Means CPU is executing all the processes. CPU executing P1, CPU executing P2, CPU executing P3, CPU executing P4. But if user are not able to see these progresses, then definitely it's not a kind of a good signal for the user, because user think that user can suppose that the process is not executing, so it cancel that running process. So this thing also happen. So interactivity means that user want to see all the processes executed. User want to see all the process executed. Okay, so user want to see all the process executed. Okay, so this is what a goal of an operating system is. So I hope you understand about what operating system do, and what is basically the main purpose of an operating system. Okay, we will see these things when we solve some numerical on this. Okay, so now moving towards the solving a numerical, there are so many things that we need to understand. Is that the CPU scheduling times. Now we understand about scheduling time. Now we understand about scheduling time. Okay, so we have so many things. So you have to give up patience. You have to be concentrated here, because if you not understand these things, then you are not able to solve the question. And once you understand this thing, you can able to solve any kind of scheduling algorithm questions. Okay, so now first one is AT. Now what does that mean? That means arrival time. Now what does this mean? Arrival time basically a time at which the process the process basically arrives. Arrival time means at the time at which the process is arrived. So time at which process is arrived. So time at which process has arrived. Okay, so this is what an arrival time is. Okay, so let's take an example of what is the meaning of an arrival time. That a process come and at says that 10:15. Let's say a process come at 10:15. So 10:15, when a process is come in a main memory, when process is come in a main memory. So, remember this thing as well, that arrival times of numerous process will be same, arrival time of so many process will be different. For example, if the arrival time, let's say 0, and for 0 we have two processes, P1 and P2, this thing also gonna happen. Arrival time is 1, we have only one process, let's say P3. Arrival time is 2, we have P4, P5 and P6. So this thing is also gonna happen. At the same arrival time we can get so many processes. Okay, so what is an arrival time? Time at which the process has arrived to basically execute. Okay, now right now the process is not executing, the process is arrived in a main memory, the process is in a memory. After that we have another thing which is called a BT, which means burst time. Now burst time, or you can say a service time as well. So now does this mean, what the meaning of a burst time? So burst time is basically a time of a process, amount of a time a process run on a CPU, amount of a time the process is spent in a CPU. So amount of a time process is spent, or you can say the process run on a CPU. What does this mean? This is a very simple line. Means we have a CPU. Okay, let's say we have a CPU process, let's say P1 is executing. So P1 is executing till 10:15 to 10:25. Process is executing from 10:15 to 10:25. So this is what the process spend time on a CPU. So this is what a burst time is in a simple way. Okay, for now this is what a burst time is. Okay, burst time means the amount of a time process is spent on running on a CPU. Means right now process is not waiting in a CPU. For example, P1 is running on a CPU. Okay, so after some time what gonna happen is P1 want to perform IO event, P1 want to perform IO operation, and P1 is performing IO operation. So now what gonna happen is, if he perform IO operation, means CPU is now become an idle, CPU is not executing P1. So this time exclude this waiting time, the time at which the process is executing, that's called a burst time. So the amount of time process spend or process run, not spend, spend is not a correct for now. The amount of time process run on a CPU, the amount of time process run on a CPU is called a burst time. So I hope you understand this thing as well, what is a burst time. After that we have CT. CT means the completion time. By its name it is clear that when the time at which the process is completed, means when process is execute fully, when the burst time is completed, when the burst time is completed, yani means end of a burst time is basically a completion time. Simple. Okay, so the time at which the process completed, now process is fully execute, user terminate the process, the process is basically terminated. So what is the completion time? Time at which process completes is called a completion time. We will see these things when we solve a numerical. We are understanding these things in detail, that how we are going to find these things. Okay, now other thing is TAT, turn around time. around time. Now what is a turnaround time? Turnaround time basically the amount of a time process is spent for from arrival till the completion. Means in this case when P1 is executing on a CPU, let's say process is come at 10:15 and leave at 10:25. So the amount of time the process spent in a CPU was from 10:15 to 10:25, means it spent 10 minutes in a CPU. It's spent 10 minutes in a CPU. So 10 minutes is basically a turnaround time. This 10 minutes is basically a turnaround time. Okay, so I hope you understand this thing, that what is a TAT? Amount of time process is spent in a CPU. So you can write it that amount of time process is spent in a CPU is basically called a turnaround time. And the formula to finding a turnaround time is what? Arrival time or completion time. The formula of TAT is what? Completion time minus arrival time. Means the process is completed and the process is when the process is basically start. When you subtract these two, the resultant answer is basically a turnaround time. Okay, so it's very easy to understand TAT as well. Now we are moving towards the next thing, which is called WT, means waiting time. So by its name it is also clear that what is the waiting time? Waiting time is the amount of time the process wait in a ready state is called the amount of time, because process's arrival, let's say the process is arrival at 10 okay, so this is our memory, this is our let's say this is our ready queue, so in ready queue we have P1 process and P2 process. P1 is waiting. Why it's waiting? Because it want to perform something, like for IO event or anything that P1 want to perform, it wait for completion of that thing. Okay, so P1 is what right now is doing. P1 is waiting till the completion of some event that P1 needed. So what happened here is P1 is waiting in a ready queue. So this is what a waiting time is. When the process spend time in a ready queue is called a waiting time. Okay, so why waiting? Because you want to perform some operations like IO operations or for anything P1 want to perform. So it wait till the user given input or anything given input. So that waiting time is that wait is basically a waiting time. Okay, so amount of time process waits in a ready state is called waiting time. So amount of time process waits in a wait in a ready state is called wait time. And the formula to calculating the waiting time is turnaround time minus burst time. Now this is what the basic thing that you need to understand. Okay, now we see one overview of these things, that because right now it's a little bit complicated to understand these things. So in a short, I explain you that what is these things. So let's say at 10 the process is come. When process is come at a, let's say we have a process P1 and P1 is come in a ready state, in a ready queue at 10 am, or in a main memory or in a RAM, the process come at 10 am. So this is what arrival time, when process arrive. Okay, the process is spent time from 10 to 10:10. Process basically the process is the time of the process till the arrive and till the complete is what? 10:10 to 10 from 10 to 10:10. So this 10:10 is what? A completion time. process arrive at 10 and complete at 10:10. So what's the difference between these two? What's the difference between these two? 10 is the difference. 10 minutes is the difference. Let's say it's in a minute, but so 10 minutes is basically a difference. So we understand about arrival time, when process arrive in a arrive to execute, and when process is executed, when process is terminated, that's called a completion time. The difference between the completion time arrival time means that process spend time in a CPU. The process spend time in a different states is what? 10 minutes. Okay, so these 10 minutes called turnaround time. These 10 minutes is called turnaround time. What is the turnaround time? Completion time minus arrival time, or you can say the process spend time in a memory, or process is the how much time the process is spent in a CPU or in a different states. That's called a turnaround time. That's called a turnaround time. The amount of time process is spent in a CPU. TAT. Okay, so this is what a CPU, and let's say P1 is spent 10 minutes here to execute. P1 is P1 CPU is executing P1, and P1 take 10 minutes to execute fully to till the terminate. So these 10 minutes is basically a turnaround time. Okay, these 10 minutes is further divided into 3 minutes and 7 minutes, let's say, because every time the process is not executing, there is a sometime when process want to perform some IO operations. Okay, the process want to take data from somewhere else, or process want to provide output for to somewhere. So the CPU has to wait. The CPU have to wait. So let's say that 3 minutes the process is spent time to executing itself. Okay, now 3 minutes the process is really executing. Process is executing, and 7 minutes what it do? It perform IO event, means the process is in a ready state. Process is in a ready state. Okay, 3 minutes for executing a process and 7 minutes to collect an IO event. Okay, so now it further divided into two parts. So the time that process is executing means the time that CPU really work on the process, this time is called burst time. This time is called burst time, and process wait to execute. So, by getting some input, so the waiting time of this 7 minute means this waiting time, this wait is called waiting time. So I hope it is clear to you that what is the waiting time, AT, CT, TAT. Everything is clear to you now. Now we are moving towards the next thing, which is also very important, that there are some more scheduling times. That's also very important, that you need to understand that these things as well, that RT, which is called a response time. RT means response time. What is the response time? Time from arrival till the burst time, burst execution of a process is basically a response time. And when the process is working on when a CPU is working on a process till the arrival, remember this thing. Burst time is different. Burst time is what? Burst time is basically a time the process is executing in a CPU and CPU is working on a particular process. But what is the response time? Response time is arrival time till process completed, process terminated, burst time. This is what a response time is. So time from arrival, time from arrival till time from arrival till time execution of a process. Time execution of a process. Time execution of a process is basically a response time. After response time, we have scheduling length as well. Scheduling length, by its name it is clear to you that what is the scheduling length. It's basically the length Okay, so you understand this with the help of a formula, that maximum time it take to complete means we have a numerous processes. Let's say processes like P1, P2, P3, P4, we have so many processes. So maximum completion time, the process which take a maximum time to complete, let's say P1 take 27, P2 take 6, P3 take 5, P4 take 10. So who take a maximum time to complete? P1 process. So that P1 process time, which is a 27, minus the minimum arrival time, is basically a scheduling length. So arrival time, let's say all processes are come at a 0. Okay, so 0 is basically arrival time of all the processes. So you can choose any process. So the difference of these two is basically a scheduling length. Difference of these two is basically a scheduling length. So I hope it is clear to you that what is the scheduling length. Max of completion time process and minimum of arrival time process is basically a scheduling length. And the last but not the least is a throughput. Now what is the throughput? Throughput is basically the number of process executing per unit time is called a throughput. Number of process executed per unit time is basically a throughput. Okay, and what is the main motive of CPU scheduling? To get a maximum throughput, that CPU will executing so many processes. For in this case, P1 is CPU is executing P1, P2, P3, P4. Every process CPU should be executed. Okay, so for that we have so many algorithms. Now we are going to understand this so many algorithms. Okay, for now we understand all these things, all the time things. So what we are going to do is we understand about some scheduling algorithm. Now we are seeing some very famous scheduling algorithms. There is FCFS, which is first in first serve, SGS, SRTF, HRR, and priority based, round robin, multi-queue scheduling, and multi-feedback scheduling. So these are all the scheduling that we are gonna study in our upcoming videos. Okay, so click on the next video to understand about FCFS and SGF. And this video, this is all about that, all about CPU scheduling, all about the scheduling times. Okay, so thanks for watching this video. Like the video and subscribe my channel.